Hello fellow AGD coders, and welcome to another video. Today we're going to continue our look at lookup tables, and we're going to look at how we can make use of the jump table to allow custom jumps, and a little bit later on we'll also look at how we can use the jump table to control sprite movement as well. So let's take a look at the jump table, and here it is. And as you can see here, most of you will know how this works. You basically move these lines about and set the jump to be as you want it. Now what you may not know is that each of these lines here represents a number that tells the sprite how far to move, and it is basically a version of a lookup table. And as you can see here with Minor Willy, you can see he's jumping about, and that's because the jump table has the series of numbers which tells AGD how much to move the sprite, and there are a total of 21 iterations, if you like, of the movement, and that's how you get that smooth transition. So let's see what happens now if I pick up this, and you'll see all of a sudden he can now climb right to the top, because basically what I've done is I've changed the lookup table, I've changed the jump table to be slightly different so that he can jump higher. So this will basically allow you to customize the jump table. Now obviously AGD only has one jump table, those 21 bytes, so what we're actually doing here is changing it on the fly. And if I basically interrupt the code here at the point where Willy can jump higher, you can see here I've altered the jump table within the code itself, and I've done that by using the object to lookup table code. And if you haven't watched the previous videos on lookup tables, then you should certainly do that, because otherwise some of this probably won't make a lot of sense. As you can see here, when I start the game, I actually load the original lookup table in so that it starts as normal. Okay, so let's take a quick look at the ASM and where it's stored. As you can see here, I've stored it at 31704 right here, and I'll make this available for download so that you can load it in. So this is quite a common place to load assembly code in, because it's not used, those characters are not really used. And as you can see here, I've got two different objects here which are basically storing the jump information that would normally be in the jump table, and I've got two different ones. The first one is the normal jump, and the second one is the big jump. So let's take a look. How do we get that data over into the object code so that it can be read? Well, basically we go into the jump table here, just go back in, and because we know the address, then all we have to do is go to Save Binary Data, choose a suitable name here, and as you can see I'm calling it 36238, and the reason for that is that that is where the jump table is actually stored in memory, so that's worth noting that number down. So there we go, saving 21 bytes just like that. That's a standard jump table. And now I've got a binary file. Well, actually I think what I'll do is I'll just make some changes just to show you that this will work. So I'll just make some little changes here, and I'll make it something obvious. I think I'll make him sort of float down at the end of his jump like that. Okay, so I'm going to save that now as a different pattern. So basically what you can do here is you could save off a whole set of different jumps depending on what you wanted to do, depending on which game you wanted to use as well, and then just load them in. So I'll save a new one here. Remember, it's 36238. It's always a good idea to put that at the start of the code so you know where to load it. We'll call it float, and I'll basically save it off here, 21 bytes, just like that. Okay, now just to show you that that works, I'll go in here. You can see there's the changed jump table. I'll load a binary data, and let's load the original one back in. So it was this one here, _new, and we'll load that back into the same address here. You don't need to have the jump table open, it's always in there. So as you can see there, we've gone back to our previous model. So let's load the float one back in just to show you that. Okay, and we'll load that in, same address, and there we go, that should be loaded. Yeah, now none of these jump tables are actually going to be in game at the moment, because I'm actually loading a jump table from an object. So as you can see here, it hasn't actually affected him at all, and that's because the original one has been loaded back in at the start of the game from this object here. So in order to introduce a different jump, what I'll have to do is basically load it in over the top of this particular object here. So let's take a look at how we do that. We just load the binary. Let's say we choose this one here as a float, and now we use the address above there for the object, which we know where it's stored, and we'll load that in over the top. And if we now try it, there you go. So I've got two different types of jump. One is stored in object 1 and one is stored in object 2, and the code, which we'll look at in a moment, is basically set up there to do that. And if I now go back to load the standard jump back in, so this one, which was a little bit higher than the previous one, then you'll see that that should work. Just a second, and oh no, that hasn't worked, and the reason is that I've loaded it in on the jump table, so I should have loaded it in to the object. Easy mistake to make. Okay, so let's do that now. Let's go back, and 38890, there we go, load it in. Just a second. 38890, there we go, and update. Yeah, there you go. So I've loaded the new one in. Let's see if that works. Yes, good. Okay, so obviously keep track of your objects and try not to get confused like I did just then. Alright, great. So that's basically how that works, and I've got two jump tables. Let's take a look at how they're actually loaded. Now again, you'll need to be familiar with the previous code, where here what we do is we're repeating 21 through a loop. So we're looking at each byte of an object, object 1, and opt means start from 0. Again, watch the previous videos if you're not familiar with this this code. And what it does, first of all, it will load that object into the memory under the value of the variable rand. Now what I'm doing here, basically this code is just pure ASM, and it is copying the value that it gets over to the jump table. And I didn't really feel the need to store that ASM as a separate piece of code, because it's only 4 bytes. So basically I've changed the code, and what it's doing now is it's just copying that data over, and this is triggered here by hitting the ball. Again, if you've seen the previous video, then you'll be familiar with this. Hits the ball, and J is set to 1, so it's a trigger to run some code in the main loop. And so when J is equal to 1, as you can see here, if J is greater than 0, let object J, let opt 0, and basically load that code in here. And obviously to load the second type of jump, we would set J to be 2. So basically here we are loading type 2 here, and when the time runs out, as you just saw, we set it back to 1. So either 1 or 2. And obviously if you wanted to have more than one different type of jump, then you could quite easily do that. Just add more objects and have a play about with that. So yeah, that's pretty much it. As I said, do go back and watch the previous videos if some of this doesn't make sense, because it certainly will if you've seen the previous videos. Now let's switch over to another technique that you might find interesting, and that is using jump tables to control sprite movement we're going to do something very similar here. We're going to store data in the object table, but we're going to use the jump table as a means of designing patterns for sprite movement with up to 21 different movement patterns, if you like. This is going to work for a horizontal sprite. We're just going to make it move left to right, as you saw here, and we're going to define up and down movement only. And as I'll show you here, I'll load in a previous design here just to show you. And again, so you can save off different designs and different patterns this way. One of the things that makes it quite handy, especially if you prefer this kind of visual data. It's easier sometimes than just working with pure numbers. So that's basically how you could load it in. And you know, I could make some small changes here if I wanted. And generally with this kind of movement, what you want to do is try to get it so that obviously the start and the end of the movement match up, so that the sprite doesn't start drifting up or down the screen. So yeah, I'll just save off another copy here like this, and then I'll show you the effect that that has. So let's take a look. As you can see here, I'm going to load it, of course, into object 1 in this case. I'm not using the jump code here now. I'm using a sprite movement code. Of course, you can create as many objects as you want, up to more than 200 if you've got the memory. So you can certainly save a lot of different patterns and different things if you wanted to do it. And so there is a basic pattern, and as you can see now, because I've got the code set up to have the sprite move in this way, it's basically moving in a completely different way to what it was before. And what we're essentially doing here is all we're actually doing is reading from the table each time we get a number, and then we're just adding it to X on a loop. And when it gets to 21, we just go back to 0. So we're using something like parent B, and parent B is then rotated around 21 from 0 all the way across, and each time it adds a different number. So you can basically create that effect. So let's take a look here. If I make some changes, as you can see, I'm just going to make it do a kind of a sort of zigzag pattern. I'll just try and line it up so that it matches. It looks about right. You can always make the adjustments later. You can even make adjustments within the code itself as well. You can still add and take little bits away from X if you want to. So now I save that off. We'll call it we'll just call it zigzag here. And fortunately I know the number. I didn't write it in there, but I can remember it. So there we go. And let's go back, load it in to the object here, and yep, we'll just load that in, and now we'll load it in at the object address, and there you go. You can see it's updated and changed, and lo and behold, our sort of bat creature is now fluttering about in a completely different way. But as you can see, it matches the pattern that we had in the original jump table.